What if I told you that mind reading was possible? What if I could take a picture of your brain, read it, and predict that you were seeing a cat or a house or a face? Believe it or not, this exists. It's not called a superpower, it's called brain decoding. Like most parts of your body, your brain consumes oxygen when it performs actions. Every time you take a selfie, read, or talk to someone, your brain is hard at work. Blood, which carries oxygen molecules, rushes into your brain to replenish this consumption, like when you eat a meal after a hard workout. The way we take images of the brain is through functional magnetic resonance imaging, or fMRI, and it is an extremely complicated subject. All you need to know, at least for now, is that fMRI machines measure oxygen levels within the brain. And because the brain consumes energy when performing tasks, this in turn means we can measure brain activity. You must be asking, how does this relate to mind reading? Well, when you see a shoe, specific parts of your brain will activate, meaning that blood will flow into specific parts of the brain. When you see a house, other parts of your brain will activate. Different objects provoke different activation patterns. If we have many examples of what your brain looks like when it looks at specific objects, we can predict what you are seeing by looking at differences in these patterns. The last component of brain decoding is machine learning. Machine learning is just a bunch of mathematical formulas that refine themselves through data rather than manual instruction. In order to draw connections between what you are seeing, such as a shoe or a house, and the brain data itself, which is just a bunch of numbers, we need to use machine learning. An example of a simple machine learning algorithm is called k-nearest neighbors. Say, for example, I have two sets of points, green and blue, and each point is described by some coordinate, x and y. The idea is that if I have a point whose color I do not know, I can place this point onto the same coordinate system and see which points are closest to it. In other words, I judge the category of a point by how much it resembles the points I am sure of. In this example, there are two green points to one blue point, so I can conclude that the unknown point is green. This algorithm can be applied to data of higher dimensions, which means I could have data that are described by more than just the x-y axes. Really, my data could be put into any coordinate space and the math would still work. Do you want to learn how to do this, but you're doubting yourself because you're missing a background in neuroscience or programming or math or all three? Well, I was just like you. When I tried to follow a brain decoding tutorial online, I was confused right off the bat. I didn't understand the concepts nor the technical terms, and so I decided I'd create a tutorial that would start from ground zero. It will take you through everything you need to know in the subjects of neuroscience, machine learning, and programming in order to do it yourself. On GitHub, my brain decoding repository contains 5 documents that will introduce you to brain decoding. The fMRI crash course and machine learning crash course files will teach you all the theory you need to know. The brain decoding file is the brain decoding process itself. The discussion file is where I reflect on the process of building the tutorial and where I talk about what worked and what didn't. Finally, the requirements file lists the necessary libraries to run the analysis. Additionally, you can load my GitHub repository with Binder and execute the whole project in a Binder environment, regardless of what libraries you have or haven't installed. Let's get started.